All right, we're going to learn a lot of different reactions with the different derivatives that we have, but overall, most of the reactions are going to be pretty much the same. So it's really important and time saving for you to kind of notice the overall themes and trends, and then just apply the little nuances of each reaction. Most of the reactions that we're going to learn are called nucleophilic acyl substitution reactions, right? Nucleophilic because we have a nucleophile attacking our acyl, which is basically just our carbonyl, and then doing some kind of substitution reaction, right? It was one thing and now it's going to be something else. And so overall, our carboxylic acid and derivatives are going to be significantly different from our ketones and aldehydes. So let's take a quick look into why. So we'll have ketones slash aldehydes up here. And then we'll have our carboxylic acid derivatives down here. And let's take a look at what they do. So for example, for a ketone or aldehyde, we have two R groups, where R would be another carbon or possibly a hydrogen in the case of an aldehyde. Whereas our carboxylic acid groups, we're going to have this oxygen, and we're going to call this other group Y. This Y group just depends what it is, right? Carboxylic acid, it'll be alcohol. Ester, it'll be some OR group, that kind of thing. And when we add a nucleophile to each, the same thing happens. The nucleophile is going to attack that electrophilic carbon attached to the oxygen, right? The oxygen is more electronegative, so it's going to make that carbon partially positive, and thus electrophilic, so our nucleophile is going to attack that position. Then what we have is a tetrahedral intermediate, and it's important that we do identify this is indeed a tetrahedral intermediate. There's a lot of evidence that says, this goes through some kind of tetrahedral intermediate. And so now we have to think about what are our options here. In our nucleophilic acyl substitution, what's going to happen next is that our lone pair on our negatively charged oxygen is going to reform our carbonyl. And then in this case, we're going to kick off our Y group. So our Y group is essentially going to act as some kind of leaving group. And then if we think about the other product, the product at the end, we reformed our acyl compound, except now instead of having the Y there, we now have a nucleophile there, right? So we did some kind of substitution reaction. We took one thing and we substitute it for another. If we try to do that same thing with our ketones and aldehydes, when we kick back down and we think about kicking off another group, if we think about kicking off our R group and our hydrogen group, that's not going to work out because they're not good leaving groups. Right, our H minus and then like a C minus are going to be very relatively unstable, and so they're not going to be good leaving groups. Instead, the reaction is essentially going to stop right there, except of course we can protonate it, right? So instead, this can just pick up an H plus, and then becomes some kind of alcohol. Right, so notice up here what we've done is an addition reaction. Right, we've just added things to our compound, where below we've replaced one thing with another. So overall, this general kind of mechanism is, we're just going to basically repeat this again and again and again with some slight changes.